Section 8.4, Rationalizing the Denominator. We simplify an expression of the form p over radical q by leaving no denominator as a radical. We call this process rationalizing. So in example 1, we're going to simplify 2 over the square root of 5, and we're going to use our calculator to show that the simplified version has the same decimal value as the original. So the process of rationalizing starts like this. We're going to write down the original problem, 2 over the square root of 5. And it's a fraction, so just like getting a common denominator, we're going to multiply top and bottom of this fraction by the same value, such that I'm going to be able to get rid of the square root of 5 in the bottom. Okay? So the only way to get rid of a square root of 5 is by making it a perfect square. To make the square root of 5 a perfect square, I would need to multiply it by another square root of 5. So we're going to make sure we do that to the top as well. Okay, so it's going to give us on the top 2 times the square root of 5 over on the bottom, the square root of 5 times the square root of 5 is square root of 25, or 5. Okay. By making the bottom a perfect square, by multiplying it by itself, I was able to get a whole number simplification. That's considered rationalized because the denominator is no longer a radical. Okay. So what we want to show is that this right here has the same decimal value as the original, so we grab a calculator. The decimal value of the original would have been 2 divided by the square root of 5. Okay, so 0.8944. And the new version is 2 times the square root of 5, my over arrow key, divided by 5. Same decimal value. Okay, so they are the exact same, it's just that one has been rationalized. Alright. To rationalize the denominator of a fraction of the form p over q, where q is positive, we multiply by 1, a fraction in the form of 1, in the form of q over q. Square root of q, I meant to say, over square root of q. We're trying to make the bottom a perfect square, so we're going to multiply by whatever it takes to make that bottom perfect. So in this example, 7 over the square root of x. To make the square root of x a perfect square, I need to multiply by the square root of x on top and bottom. So it'll give me 7 square root of x across the top, and square root of x times square root of x is x. That's been rationalized. Okay. In part B, this could be separated into 2 fractions, square root of x over square root of 5. I meant to say 2 radicals. That fraction can be separated into 2 radicals. And then we're going to multiply by square root of 5 on top and bottom. Okay, so it's going to give us square root of 5x on the top over 5 on the bottom. Okay, same thing with the next one. We're going to be able to simplify this to 3 square root of a squared square root of b over square root of 7. Let's go ahead and simplify that. I know the square root of a squared is a, so I have a square root of 3b over square root of 7. Now, we've simplified the fraction. We need to continue on to do the rationalization portion. So we're going to multiply by square root of 7 on top and bottom. So my final answer is a square root of 21b over 7. So we still want to simplify if possible first, then go ahead and do the rationalization as our last step. Alright. Alright, so a couple more examples here. Let's separate this one into square root of 5x over square root of 18. Simplify if possible, so that can be simplified. I can't do anything with the square root of 5x, but I can simplify the square root of 18 into the square root of 9, the square root of 2. So that's going to equal the square root of 5x over 3 square root of 2. Alright, so we've simplified. Now for our rationalization step, what we need to do is get rid of the square root of 2. So we're going to multiply top and bottom by the square root of 2. So the top is going to become those both inside square roots. It's going to become square root of 5 times 2 is 10, so square root of 10x, over, this is going to be 3 times the square root of 2 times the square root of 2 is 2. So I've got square root of 10x over 6. Okay. And in the next one, something similar. We're going to start with the square root of 7, the square root of w squared. I'm separating those because I can take the square root of w squared over the square root of 20, and the square root of 20 I'm going to break into the square root of 4 and the square root of 5. So this will be w square root of 7 over the square root of 4 is 2 times the square root of 5. I'm going to rationalize the bottom here by multiplying top and bottom by a square root of 5. So it's going to give us w square root of 7 times 5 is 35 over 2 times square root of 5 times square root of 5 is 5, for a final answer of w square root of 35 over 10. So simplify our radicals first. Rationalize the bit of the radical that's left if there's any radical in the bottom. It's the denominator that I have to rationalize. Alright. Objective 2, rationalizing denominators that contain two terms. Okay. So in the last section we saw that to get a whole number, I need to multiply the numerator and denominator by the conjugate of the denominator. If I have two terms, I will get a whole number by multiplying by the conjugate. So in this case, where the denominator is a square root of a plus square root of b, the conjugate would be square root of a minus square root of b. Top and bottom. Okay. So in the case of example A right here, we would have 1 over 4 minus square root of 3 times our conjugate. So our conjugate is going to be the same two terms with opposite sign. So it's going to be 4 plus square root of 3 on top and bottom. Let's throw some parentheses in there so we can make sure we use the distributive property. On the top, 1 times everything, so on the top we're going to have 4 plus the square root of 3. And on the bottom, 4 times 4 is 16. 4 times square root of 3 is 4 square root of 3. Minus 4 square root of 3. Minus 3. Now remember, because this was a conjugate, so we're expecting our middle terms to cancel. They're going to. So we're going to end up with 4 plus the square root of 3 over, okay, those subtract to 0, so I've got 16 minus 3 is 13. Final answer. And the last problem, the conjugate of the bottom, that's square root of 6 plus square root of 3. So the conjugate would be square root of 6 minus square root of 3. Multiply top and bottom by square root of 6 minus square root of 3. Let's throw some parentheses in there so we can get our distributes right. So the top is going to be 6 times the square root of 6 minus 6 times the square root of 3 over square root of 6 times square root of 6 is 6. Square root of 6 times square root of 3, that'll be negative square root of 18. Square root of 3 times square root of 6, that'll be positive square root of 18. And square root of 3 times negative square root of 3 will be negative 3. Okay, so I've got 6 square root of 6 minus 6 square root of 3 over negative square root of 18 and positive square root of 18 add to 0. And 6 minus 3 is 3. That's good. It's rationalized, but I actually noticed that it's not quite done. Remember that we can reduce if we can divide through, if we can distribute our division right here. So since this 3 can divide into both of the 6's, this will reduce to 2 square root of 6 minus 2 square root of 3. The distributive property works for both for both multiplication and division. So since this 3 we're going to divide it evenly, and we're distributing that division right there. 6 divided by 3 is 2 square root of 6, and 6 divided by 3 is 2 square root of 3.